We didn't do it. Yeah, we go maintenance, just do like a service. Like.
All right, let's do attendance. Signing, signing. Daniel. Daniel?
No. Sorry.
Oh, so Dan, right?
Yeah.
I thought you go by Dan. Okay. Daryl?
All right.
All right. Isaiah? Isaiah. Jeffrey? I saw Ralph. Sean? Sean?
Yes.
It's you.
I'm here.
Sarah? Sarah? Let's do it. Oh, let's do it. Let's do it. All right. We are officially in the race. Private school students. Day 2, very simple, straightforward. It's only going to be aerodynamics. And in aerodynamics, or I should rather say aerodynamics will be divided into 2. It will be divided into today and tomorrow. And it will follow us for much longer than that. But those 2 days are designated for aerodynamics. On top of that, tomorrow as well, it's going to be half kind of like aerodynamics. Then it will be followed by the piston engine and how it works. So we're going to be talking about that. In your Cessna training app, I hope everybody got it by now. Airplane, engines, and systems. That's where you should be. That's what you should have finished by now. So let's go straight to the. Hello. What's your name?
Marshall, I'm not in this class. I'm just gonna sit in because I don't have my PPL yet.
Okay.
I'm like close to it, but I came out here without it, so I just want to kind of absorb it.
Okay, sounds good. All right. Week 1, day 2. Let's see if somebody is online on the Zoom. No. There you go. Aerodynamics and the principles pretty much. A plane in general can be divided into obviously some type of categories, right? Or sections. Each plane is known to have a fuselage, which is from here to around here. That's the one where you would carry people, you would carry cargo in the fuselage, right? Then you have the so-called power plant, which is in the very front in our general aviation plane. Okay, the power plant is in the front, in front of the fuselage. And at the very back, you have the so-called empennage. Exactly. And all of these are components of an airplane. As simple as it is, and as simple as it is here on this little picture. Under this fuselage, you will find your landing gear. And that landing gear doesn't necessarily have to be only on the fuselage. It can also be on the power plant. For example, the nose gear can be an extension of the power plant. So on top or below the fuselage, you have the wings. In our case, it's going to be below. Very straightforward. At the very bottom, at the very end of this, at the empennage, you have the vertical and the horizontal stabilizer. Okay, so just like right here. It's probably going to be in the next, yeah, in the next. All right, very straightforward. Fuselage in the middle, wings up or down, depending on the type of plane. Landing gear below it, power plant in the front, empennage. And now we're going to look a little bit more into detail in regards of this empennage. The empennage, like I said, has a horizontal and a vertical one, right? This is vertical, top to bottom, horizontal, left to right, east to west, whatever you want to call it. And we saw, for example, yesterday that on the elevator, which is on the horizontal one, okay, we have the trim tab. And the trim tab for the sling is, for example, only on the left side of that elevator, on the horizontal stabilizer. On the vertical stabilizer, we saw that we have not only the antenna on top, but we also saw that we have our rudder that we will control with the inputs with our feet. Okay, with the pedals that are down there, you control the rudder. And on the ground, you control the steering with that. In the air, you control something else, and we talk about that later. Okay? So pretty straightforward, right? You have the horizontal, and you have the elevators on the horizontal with the trim tab. You have the vertical, and you have the rudder. Some have even rudder trim. We don't have that in the sling, but if you make it to the multi-engine, they have a rudder trim, for example. So, any questions so far? Pretty straightforward, right? The four forces of flight. This is kind of like the I don't know, the 101 of flying. The four forces of flight, okay? There's four forces that a plane has to overcome, or that a plane faces, pretty much, I should rather say. There's the force of the so-called lift. There's the force of the so-called weight, right? So we have lift, and lift is opposing weight. Okay, so these ones are, if you want to say it like that, they're fighting each other. They're trying to compete for who's going to get most of it, or maybe they're going to be in balance. Okay, then we have thrust, and we have something that is considered to be drag. Okay, and these are also fighting against each other. They're either fighting against each other or they're in peace and they're at an equilibrium. Okay, a plane that you find outside right now is not going forward, not back, so they're equal, right? It's also not going up or down, so it's equal right there as well. So that's a plane in equilibrium. A plane can also be in equilibrium when you fly it at 100 knots and you're not descending and you're not descending or you're not climbing. If you're flying 100 knots and you stay at 4,000 feet, all these forces are equal to each other. Lift is equal to weight because you're not climbing or descending. Thrust is equal to drag because you're not going faster than 90, but you're also not going slower than 80. You're maintaining 90. Okay? So the forces are going to be equal, or when they are equal, thrust will be equal to drag, lift will be equal to weight. Okay? And that can be at different scenarios. This scenario can also be in a climb. If you're climbing now at 500 feet per minute and you're exactly at 90 and you're stable at that 500 feet per minute, all your four forces are equal again, right? Because you're climbing or descending, they're equal to each other because you're constantly climbing at that 500 feet per minute, okay? You're not going faster than 90 or you're also not going slower than 90. You're climbing at 90. Any questions? Good. So the four forces of flight. Lift is the upward vertical action that opposes weight. We just said that. Most of the time, sometimes I say it and then I see they have a slide. I really don't go over the slides like that. So it's going to be a review, so it's not bad. So lift is the upward vertical action that opposes weight. The amount of lift produced is controlled by the pilot via the plane's control surfaces. Okay, so the elevator input that you put in, either down or up, is going to make the plane go up or down. Okay, and that's going to create lift. Occurs only when the plane is moving forward and airflow is present over and under the wings. Obviously, the plane cannot lift itself. Technically, I don't know. Yeah, it technically can, but okay, we're not gonna go there. Yeah, when it's moving forward, it creates lift or it creates something weight, right? The thing I was thinking about was like gust, right? A plane on the ground that is faced with gust can be lifted up and flipped around. But there's a force still, like there's some forces that come into play. Produced by pressure differences on the upper surface and lower surface of the wing. We will discuss that later. All right, so the four forces of flight. Now we talked about lift, there's weight, and that's exactly what lift is facing, okay? Weight has a definite relationship to lift. Lift is required to counteract the aircraft's weight and stabilize level flight. When the lift force is equal to the weight force, the aircraft is in a state of equilibrium. You will hear that many times. Maybe you will have to explain it one day. The state of equilibrium for lift and weight is when you reach, for example, one flight level, okay? And you stay at that flight. If lift becomes less than weight, the vertical speed will decrease, right? If lift is greater than weight, then the vertical speed will increase. And all of that will be discussed. Pretty straightforward right now, right? It's plus or minus, or if they're both matching, it's equilibrium, equal, all right? Thrust. Then we got thrust, the forward force produced by a power plant, propeller, or rotor. It opposes or overcomes the force of drag. In regards of a sling, for example, you have the power plant in the front. The power plant is going to produce some type of energy that then will be translated into the propeller. The propeller is the one that creates the thrust through the power plant. It's a direct relationship right there, right? If you don't have a power plant, you're not going to move forward, right? If you have a power plant but no propeller in the front, you might, or most likely will not move forward either, right? So there is a direct relationship in that. So power plant, propeller, creating thrust. If thrust is greater than drag, okay, then we'll move forward. If drag is greater than thrust, you will not move backwards, but you will slow down all the way until you come to a standstill, okay? If Craig and me, I'm holding Craig's shirt, Craig is trying to move forward, if he's overcoming my force, he's going to move forward. If I'm overcoming his force, he's staying there where I am, okay? So as simple as that. Pretty clear? Drag, same thing. But here we're going to talk about the different types of drag because these are going to be important and they will follow you forever. And once in a while, I'll give you a little bit of backstory, okay? So, the private pilot and why I highly recommended that Gold Seal program, if you have time for it, maybe you guys can even get together, 4 people, everybody pitches in $50 or something, you share their profile. Is because I think the reason, I don't want to talk about myself too much, but the reason why I was able to succeed past was because my foundation was very strong, okay? I came in and I had already the Gold Seal done. And I really committed like 2 months to that Gold Seal program. So I sat down every day for 5-6 hours and I just studied it. And I realized that even when I got to instrument or later commercial, everything is kind of like repetitive, but just build on top of it. Okay? Because forces of flight will not change. But later on, you will maybe talk about coefficient of lift and coefficient of drag. Okay? But now you're just building on top of the idea of forces of flight. Okay, or forces of lift and drag, okay? So build a strong foundation if you can, because it will also help you later on in the commercial instrument, all of them. All right, my 2 cents for today. Drag is the force that resists movement of an aircraft through the air. All right, the amount of drag can and will change during almost all phases of flight, okay? It's pretty straightforward. It cannot be fully controlled by the pilot. You cannot really control drag that much, right? Like the weight of the plane, you cannot really control, right? The weight of the plane can create drag. You cannot control the average use of fuel that the plane has, right? So your weight is going to go down as you fly longer, right? Because of the fuel that you have just burned. So drag is a component that you cannot really control that much. But you can control in the sense of overcoming it with thrust. Everybody's understood that?
Mm.
Yeah? If you add power, you overcome drag. And that's your ability to overcome drag. Okay, the amount of drag can and will change during almost all phases of flight. It cannot, for example, drag is very high at a takeoff. And once you're in a kind of like constant 4,000 feet, 90 knots again, drag will go a little bit, it goes less, right? Or if you go into what's our best glide speed? Anybody know already? I heard it somewhere. 72, yeah. So if you put your plane in the 72, you create the least amount of drag. So now as a pilot, you also have the ability to somewhat determine how much drag you're creating, right? The plane being put in 72 is the least amount of drag that you can create for this plane. All right, broken down into two basic types of drag, and this will be discussed later. There's something that's called a parasitic drag, and there's something called induced drag, okay? And we're gonna talk about it later. There's three types in the relationship. Okay, so there's drag, that's the umbrella term. And then from that, there's two things that branch off. There's parasitic drag, and there's induced drag. Parasitic drag has three types of drag. Okay? So there's drag, parasitic, and then under parasitic, you'll put a category of three different drags, okay? We're going to talk about later. It's interference, form, and skin and friction, whatever. The other one is called induced drag, but under it, there's nothing really. It's only induced drag. Everybody understood? All right, this one will follow you forever. Bernoulli's principle, which is pretty much a theory. Anybody know what it is? John, what is Bernoulli's principle?
The faster you go, well, in general terms, the faster the air speed go, the lower the pressure. Actually,
Try again, one time. Yeah, it was almost there. Yeah.
almost there.
Yeah.
I mean, let me read more. If the air travels shorter distance means it's slightly a bit faster. Sorry, travel longer distance means it's going way faster. When the air travels way faster, the pressure on top is smaller. If we're talking about wings, the airflow goes from the top to the bottom. It travels a longer distance, creates less pressure on the top. While the shorter distance, flat surface at the bottom creates a little bit more pressure, hence pushing things.
Yeah, I like it. Exactly. The wing is in a shape that one side of the wing is straight almost, and the other side is curved, right? The wind or the relative wind will be split at the leading edge. Right? So that's a term you probably have to write down. The leading edge is where the wind will be split. And it will go under the wing and it will go over the wing. And there's a tendency in nature, even when we talk about weather later, that high pressure always tends to move to low pressure. Okay? And high pressure tries to move to low pressure, and the high pressure is under the wing, trying to push itself up or trying to rejoin the low pressure, which has a longer distance to travel. Okay? We will see it in many pictures now, but just follow me for right now. So the first thing that you read in the PHAC under aerodynamics is air is a liquid. Okay? Air is considered to be a liquid. And a liquid has to travel. And they say also that, or Bernoulli principles, or Bernoulli's theory, is that the liquid that's trying to travel or has a longer distance to travel will be faster because they're trying to join at the end. The liquid or the air that is traveling from the top will be traveling faster. And anything traveling faster will result in lower pressure. A liquid that is traveling from underneath the wing will travel not as fast as the one on top, and that will create a high pressure. And in a nutshell, high pressure tends to move to low pressure, and that's how you have lift. Okay. So let's read this here. In fluid dynamics, there's a full study on this. Okay, there's a entire, I think, major in regards of fluid dynamics. In fluid dynamics, Bernoulli's principle states that an increase in the speed of a fluid occurs simultaneously with a decrease in pressure. That's what we said, right? The wing on top is curved. Since the air has to travel a longer distance, it's going to be faster. It's going to travel faster. And anything traveling faster will create low pressure. That's all it says here. That an increase in the speed of a fluid occurs simultaneously with a decrease in pressure. That's exactly what it says. Or a decrease in the fluid's potential energy. The air flowing over the upper curved surface of the wing is traveling at a faster rate than the air flowing underneath the wing. And that's exactly creating two things. It's creating low pressure on top, high pressure at the bottom. It's creating a pressure system. Okay? It's right here. It creates two different states of pressure over and under the wing. Low pressure above, high pressure underneath. The faster airflow above the wing is at a lower pressure than the slower. What? The faster airflow above the wing is at a, okay. The faster airflow above the wing is at a lower air pressure. We just said 5 times probably no. Higher pressure airflow below the wing. The low pressure above the wing is what lifts the wing into the air, almost like a suction. High pressure tends to move there, but it is more of a suction that the low pressure creates, okay? So it's kind of like pulling it, if anything, okay? Creating that wing to be lifted. Before we talk about Venturi, you're gonna talk about this one. So there's your wing. And this is wind right here, okay? So this is the relative wind. And this is what we call the leading edge. And now the wind is split, right? One goes below, one goes above. Lower pressure is caused by the increased speed of the air over the wing. I don't know. One guy one time explained it to us, and it just stuck with me. Maybe it was stuck with you too. You see how the wing is kind of like this? So it's like a slide, yeah? When you go down a slide, when you go down the slide, your speed goes up, right? So plus on the speed, minus on the low pressure, okay? So you increase your speed and you create the low pressure, okay? So this one is traveling obviously faster because it's going down the slide. This one is traveling the same speed almost, or lower speed at least than the one that is on top, which means here you have, maybe I should do this one for speed, okay? Less than that for sure. And then here you create high pressure, okay? So that's the entire theory of Bernoulli right now, okay? Any question? No question? Good. High pressure, low pressure, air is a liquid. Like there should be some words when I say them, you should be able to somewhat explain it to me then. Right? If I say explain Bernoulli's principle to me, you should be thinking about high pressure, low pressure, speed, and fluid, and maybe how that creates a suction. If you create these like buzzwords for yourself, that's how I study. If you create these buzzwords for yourself, you might be able to always recall it. Yeah. All right. So in regards of Bernoulli also, there's an effect. It's called the Venturi effect. This is just explaining to us how something that is moving faster is creating a lower pressure, right? Nothing else. The Venturi effect, is the phenomenon that occurs when a fluid that is flowing through a pipe is forced through a narrow section, resulting in a pressure decrease and a velocity increase. We have 200 people in this hangar. Everybody walks through the dispatch door, right? Right here. A fire starts right here in this room. Everybody's going to try to get out, right? Through that door. We all going to meet at that door, and everybody at that door is going to move fast now. It's the same with high pressure and low pressure, right? As you get closer to a bottleneck, you're going to create some type of pressure, and this pressure, because people are trying to speed out of the door real quick, they're going fast now. That's your low pressure. Okay? Different ways of maybe memorizing this. And this is exactly what it's showing here. It's just compressed. The closer it gets, the more compressed it will be. The more compressed it will be, the higher it will travel through it. This is other than like a wing now, it's just like compression, okay? Or compressed air. If you have a compressor and you have a gun with like air, the air that's coming out of it is going to be much faster than you blowing out air, right? It's compressed. Because it's compressed, it's being able to be pushed faster. Air is a liquid. Questions on this one? No question?
I don't think we actually have a venturi inside the engine, right?
No,
Those
we
are
don't.
specifically for like Cessnas, all Cessnas.
The Venturi is directly related for later, guys, for the fuel injection, okay? We have fuel injected, and there's also a different carburetor system, and the carburetor system is going to work with the Venturi effect. Yeah, right. Well, that's maybe tomorrow, the day after tomorrow, okay? All right. Let's see what we got next. So, you always know in life, that's not, unfortunately always not, I mean, maybe fortunate. When you have an idea, somebody thinks they have a better idea. And that's Newton right there. Right? Like, you guys can also have your own idea, but the only problem is probably people won't listen to us. All right, so there's Bernoulli. He came up with this theory, and there comes Newton now. And Newton thinks, yeah, no, my idea in regards of how lift is produced is much better. Okay? And all he's saying is that when there's a action, there has to be an opposite and equal reaction. Okay? As simple as that. So the wind. Root over here. So the wind, let's say you're here, and you're putting the plane into a angled position. The wind that is going to hit right here is going to have an opposite and equal reaction, says Newton, and the force will push the plane up. That's literally what he's saying. Okay. Anything has an opposite and equal reaction. You put the wing up, the force that is hitting the wing down here is going to cause a opposite and equal reaction. And it's going to bring the plane up like this. Because the plane is trying to push itself away from that wind that it is being exposed to. Is that making sense? It's a very simple theory, really. Yeah, and he will come also through a couple more theories down the road. Everybody understand? As simple as opposite and equal reaction. Wind is creating a force against the wind, against the wing, and the wing itself will be pushing itself up. All right. Welcome to the breakdown of the wing. Who said you? Oh, yeah? Good. The wing itself can be divided into, let's start with the leading edge and the trailing edge, as simple as that. Leading edge in the front, trailing edge obviously in the back. Okay? There is an imaginary line. This line does not exist. And that line we call the chord line. If you would cut a wing open from the side, and you put a string right through the trailing edge, the leading edge to the trailing edge, that is a chord line, okay, that we consider the chord line. It goes from the trailing edge, from the leading edge to the trailing edge, okay? And that is your chord line. So now you have the relative wind, you have lift, and a force that you create, right? All right, and there's your drag factor as well. They also tell you where center of pressure is. Center of pressure is the same as center of lift. They're interchangeable. Okay, you can say center of lift. You should not get confused what center of pressure is because it's the same. And as we are increasing our bank, or as we are increasing, as we are increasing our pitch, okay, our angle of attack will get greater. This one right here, that is being stated as A, is what we consider angle of attack. An angle of attack is nothing else than this plane being pitched. Now it's maybe 2 degrees, okay, this angle of attack. Now it's maybe 3 degrees. No, it's maybe 4 degrees, 5, 10, maybe 10. Okay? So if you take off in the sling, for example, you most likely put the yellow dot exactly on the 10-degree line, and you will see the plane will pitch up and fly out at 72. If you put the yellow dot exactly on the 10-degree line on takeoff with a sling, it will be exactly 72. Okay? And that is now you create a 10-degree pitch with an angle of attack, right? And this angle of attack is always between the chord line and the relative wind. Okay? The so-called chord line and the relative wind, the angle between those two is always considered to be your angle of attack. Everyone understand? Come on in, brother. Let me introduce you. All good?
Yeah, so I can do Wednesday through Friday.
Okay, sweet. So Zachary is going to be teaching tomorrow, Thursday, and as well as Friday. Pick his brain. Very smart guy.
Everyone, I like to see if the class is bigger than it was yesterday.
Yeah. It's a pretty cool group because they only have one class too, so you're gonna get all of them. Yeah. They're not gonna hide from us. All right, sweet.
All right,
That's
cool.
Zachary. He's gonna teach tomorrow, so be good to him. You know how to use all this, right? You feel pretty comfortable?
I'm gonna need a refresher probably, but
Yeah.
I think Declu gave me some notes on how to start it up and take attendance.
So here, if you look up there real quick,
Yeah.
you have the attendance. You just click on that link. It opens up the attendance.
Mhm.
Here's the drive, and then opens the entire drive.
And the drive has
The
the
PowerPoint there, and you
PowerPoint
just
and
need
stuff.
week 1 anyway. So, and then you go to day 3, sorry, tomorrow. So it's gonna be like this.
yeah, it's all built
And then
in.
week 1, okay? And then you go, tomorrow's day 3, which is systems, and it's confusing because you might think that the system is gonna start at slide 1, but
No,
tomorrow it
it's
starts at slide 60.
Yeah, I went through the first week.
Okay, sweet.
So I'm familiar with that. And then Flex Quiz.
That's
I
Saturday,
remember people
Friday.
getting locked out of that.
Yeah, you just go here, right here, click on Flex Quiz.
Yeah.
And even if we don't have it, you just click, and then it's already saved on this
Okay,
computer, and you just log in.
Awesome.
You know. And then the Zoom is already down here. You just
Right.
have to start it. It's down here, and it's
So
gonna
it's
say
on-
tomorrow 11, and then it will say start over here on this corner. So you
Uh-huh.
just click on that. Starts. All right,
Cool.
pretty
Thanks.
straightforward. Yeah, thanks for doing that.
Yeah,
Appreciate it.
no problem. See you guys tomorrow.
All right, so back to our slideshow. Center of pressure equal to, same, not equal to, same as center of lift. Center of pressure, if you read the book, will move forward as you increase your angle of attack. Okay, center of pressure, center of lift on the wing will move forward as you increase your pitch. And there's a certain amount of angle this plane can withstand before it stalls, but that's something else. Okay, it's just the introduction. Any questions in regards of forces? You're going to break this down a little bit more too, but center of pressure, center of lift, same thing. Angle of attack is between chord line and relative wind, just like it says here. Trailing edge and leading edge, you have to know what they are. They're pretty straightforward. Okay? Leading edge, trailing edge, there's your curved airfoil. And the chord line is the imaginary line. There's no such thing as a chord line. It's not say exactly the same. All right, relative wind. Relative wind can hit you from many different places, right? If you have a tailwind, the relative wind is probably hitting you also. Obviously, the force of the headwind is stronger than the tailwind, but you're also competing against a tailwind. Okay, it's trying to push you down, for example. It can have many effects on a plane. Okay, but relative winds can be at different situations or at different positions in regards of the airfoil. It can be directly to the leading edge. It can be coming from underneath the leading edge. Or it can be kind of like cutting through it and going more down, okay? It depends on how you position the plane as well. That's all they're trying to tell you. The relative wind is not fixed, okay? Relative wind is not fixed. It also depends on the position of the plane. All right, angle of attack between chord line and relative wind. Who knows what happens if you exceed the angle of attack?
We see the stall.
Yeah, that's a stall. Okay, as simple as that. If you exceed the angle of attack for a plane, you're going to stall the plane. Okay. There's some other factors with it. There's weight, there's speed. Angle of attack, chord line. It's so important they have 5 slides for one word, okay? Like, all right, can the angle of attack change? Yes, it can change, for example, with pitch, right? But it can also change if your leading edge and trailing edge has changed. And how can that change? It can change with your flaps. Everybody see that? If you extend your flaps and they go out, now your leading edge is somewhere, or your trailing edge is somewhere else than where it used to be, because you extended your flaps. And this chord line is a different line now because of this extension of the flaps. So the chord line has changed or shifted because of the flaps. The relative wind is still the same, but now you might have a different angle or different number of angle of attack, just depending on the change of flaps, right? All right, and there it is. Stalls as simple as this. This is the 101 of stalls. If you exceed your critical angle of attack, you will stall. And nobody wants to stall unless you're training. Okay? And stalls are not really that. I don't know, people have different feelings about stalls. In training, you should actually look forward to this. Like, this is what I think. Okay? You should really look forward to training stalls because you want to be as proficient as you can in case you find yourself in a situation the plane's going to stall you. You have an instructor next to you who hopefully will be able to, even if you are stalled and not knowing what to do, he should be able to recover the plane, even if it gets in a spin. Okay? So stall that thing and have fun. You're not going to do it at 1,000 feet. You're not going to do it over the runway. You're going to do it over there in the ocean at 4,000 feet. Just stall it, right? Like, don't fear the stall. All right, but not on the first day. Right? When he tells you stall, not like don't scare the shit out of him, yeah, or her, or whatever. Caused by exceeding the plane's critical angle of attack. Okay, as simple as that. All right, my favorite video. This is one of my favorite videos. We're gonna watch it right now. And somebody is gonna try to explain this to me. All right, hold up. There we go. One more, maybe. Maybe not. Here, one more time. All right, who wants to give it a chance? Dan.
So looks like they have their flaps down so they can have a higher angle attack, probably going really slow. And then you can see the wind over the red little flags there are all uniform because the flow is going correctly. And then when he stalls, they all rumble around every direction, which is because the wind is kind of rolling back on itself across the top of the wing.
Yeah,
Early separation.
that's correct. And if I pause it right here, which one curl up first? Let's do it.
The inside closer to the body of the plant.
Yeah, it's called the root, but also in regards of the overall position, it's these ones that curl up first. You see it? So it's at the root, but that's directly related to the wing design, okay? It has a design, it's a design thing. But it starts here at the very back, okay? And it extends. And then the next line will be this line. And then it extends. And then the next line will be, obviously, this one. But pause it real quick. You see how this one is curling up now? This one's curling up, this one. But this one's still good. This one looks still good too. Now, all of them are almost going crazy. And like Stuart said, the root, which is the very beginning of the wing, will stall first, right? And then it extends. All right, so if we think about this, come to the conclusion that not only does it start at the root or at the back, but center of lift, like I said earlier, center of pressure is moving which way? From front to back or back to front? Yeah. So as you increase your pitch, now this center of pressure is moving this way, right? And it's not supporting this part of the wing anymore. Right? It's almost like I think I read it in an article a long time ago, but don't quote me on this. It's almost like the surface area of this wing, okay, is being reduced in regards of lift. And the reduction in regards of lift, because of the center of pressure is moving forward, it almost omits the entire back of the wing, okay? Until it moves forward. And now it reaches a point where the wing is not creating enough lift, causing the stall, okay? Because this amount can create a lot of lift, right? This wing, but if you reduce the ruler side, it still can create lift, right? But less. But now if you take this amount, it will create even less, right? This amount, even less. But if when you reach that center of pressure point or the angle of attack, directly related to lift, it will not be able sufficient, or this part right here that I have on the yellow part is not going to be sufficient to create lift for this plane to be flying, and it stalls. Okay, and obviously the center of pressure or lift is only going forward because you're increasing your pitch. Right? Everybody understood? All right. Axes. Let's see how much more. I have to know how fast I gotta go. All right, we're gonna take a 5-minute break. I'll make it 10 minutes. Review stuff, and then we're gonna go to axes and stability.
You should use it time. Yeah. Are all. Question. How would you guys stay? How would you guys? Yeah. So that. Especially one probably. Maybe 4 hours. Yeah, it's filming. I think it's fine. It's like. Yeah, you know. Third from Jay, it's good for you. And also, you know, maybe. Don't push out. I'm ready to play. What's up? It's not. Zero is not looking at that. You just didn't know that one of them. 2,000 and each of the few others in content that you like. The public can have it in the time. Thank you. Oh, big man is not like, yeah, it's out here. I gotta. Make sure if my address, so we can ask for it. Like, man, it's everything, but. But he was. Yeah, I was gonna go there on some of the next time, it's bothering them, and you ask them, like, you know, publish. Okay. You, I'm on this. Getting somewhere, I feel like people that are some of those, there's some understanding that they will be next year is the better one. I'm going to be. Good, it's not a fear. Bro, I never see your eyes, I'm scared, but I don't want to pull it out, it's like when older starts working. It's just listed. I'll believe you. Yeah, yeah. That tree. Okay, I'm not seeing that. Better than buy it. Maybe I just sell them. Great. They want their bucks. Yeah, no.
All right, let's get it started. Anybody flew already? Anybody got a flashlight? Yeah. Who's the instructor? Mario. Oh, Mario. What about you? Did you fly? What? Did you fly already? No, not yet. After this? Yeah. Not yet. Dan? Nothing?
Yeah.
Nice. Nice. Thanks, Ollie. All right. So, after we talked about forces, we know all four forces. There's also something called axes, okay? The plane has axes, Obviously, you can't see it. It's imaginary axis. It's just like the chord line. There's one. The vertical axis. I'm trying to see if I can show you. Oh, there it is. The vertical axis kind of goes through the plane, okay, and it would come out like this, and that is causing what kind of movement?
Yeah.
There. Where is it? Here. So it causes, if you see this one like this, it causes the plane to go this way, right? It yaws. You see the rotation is kind of like this. So if I would turn this one, it would go this way. Okay? It yaws the plane. Then there's something that's gonna roll the plane. What's gonna roll the plane? It's right there, man.
Rollins.
Longitudinal axis. I'm gonna roll the plane. So this is your longitudinal axis, okay? Just like this, it goes from the nose all the way to the back, almost like a rotisserie chicken, and then it's gonna roll it like this. Okay? There it is. Like, longitudinal axis is gonna roll the plane. And what causes the plane to roll? It's not on there, I know.
Ailerons.
Ailerons, correct. Yeah, and then we have this axis right here, and it's called what? Lateral axis. And that's going to cause the plane to pitch. And how does it pitch? With what? Input?
Elevators.
Elevator, right? So the elevator is going to cause the plane to pitch up or down. The longitudinal axis is controlled by the ailerons, causing the plane to roll. Okay. The vertical axis is going to cause the plane to yaw. Okay. And these are your three axes. Your primary control surfaces. There is your elevator on the vertical, the horizontal stabilizer. There's your aileron. Is it closer or the further away from the further away? What's closer? Flaps. Right. So it's flaps, then aileron. But aileron is a primary. It's called a primary control surface. What's the last one?
The rudder.
Correct. And that is where? Vertical stabilizer. Yeah. Vertical stabilizer, horizontal, empennage, fuselage, wing, flaps, ailerons. Okay. These are your primary ones. What kind of secondary control surfaces can you think of? That's one. Good. One more.
Okay. The
Propeller.
constant speed propeller where you can change the attack angle of the propeller. Not exactly.
Flaps.
Secondary.
Secondary. Okay. All right. Stability. We will talk about stability. How many types of drag is there? Two. What are they?
Induced. And
The parasitic.
Person.
What about form drag? We're not about form.
That's parasitic. Yeah. Induced. Parasitic. Parasitic, I said, has three under it, right? All right. So in regards of stability, there's two types of stability. There's something called dynamic. All right. Dynamic means nothing else but over time. Dynamic is time over time, the stability over time. And then there's static stability. Okay. Static is almost like you take a picture in that moment. How stable is that plane? It's in that moment. After a updraft, downdraft has been encountered, after turbulence has been encountered. In that moment, how stable is the plane? Okay. Trainers in general, like ours, are considered to be very stable. Okay. All right, so we talked about dynamic now, and that means over time. We talked about static now, static in time. Okay. Almost like a screenshot in that moment. And now we're going to talk about, let me read this actually. Stability is the inherent quality of an aircraft to correct for conditions that may disturb its equilibrium and to return to or to continue on the original flight path. It is primarily an aircraft design characteristic. Okay, so this plane going through the air is going to get hit by something like turbulence. Is the plane going to go negative, positive? That we will figure out. Okay. Dynamic stability. So now we know there's stability. And if I would draw it in my notebook, I would draw it like this. Stability here, and then I would draw two branches. There's dynamic, and then there's static. Okay, and then under the dynamic, I would have three subcategories. There's positive, neutral, negative. Okay, and on the other side, there's stability, static. On the other side, you have positive, neutral, negative. And each one of them I would explain. Okay, dynamic, positive. Over time, that plane will go back to the same place where it used where it encountered the disturbance. Over time, it will go back to the place where it was. Dynamic, positive stability. All right. Dynamic, neutral stability, on the other hand, you encounter something, okay, and the plane is just going to continue the entire time on that new kind of oscillation. It's going to go up and down, up and down and up. Okay? That's dynamic neutral. It's not going to get worse at least, but you're going to continuously stay in that. Craig, what do they call it? The heart monitor? You said you're in healthcare, right?
Yes,
What's that?
EKG.
EKG, yeah. It's almost like an EKG, right? It's going to stay stable like that. The plane is going to stay stable, neutral in regards of dynamic stability. It's just going to continue, but it's never going to get better or not worse. Negative, on the other hand, you'll encounter something, and now the plane is going to get worse and worse and worse. So very unstable, right? Three scenarios. Stable on top, dynamic, static. Under dynamic, there's three categories. Under static, there's going to be three categories. Static, in that moment, when you encounter it, is it going to get worse or is it going to stay the same, or is it going to get better? Or, okay? So three categories in regards of static. So you have, for example, the encounter, and it's going to get statically stable, which is almost like the stable, sorry, the positive, okay? Which means you encounter it, but it's going to stay right there. All right? It's going to stay in the new state that it just encountered. Okay? Then there's neutral. You face something and it's just going to stay there now. It's just going to continue on that. A negative one, for example, let's say your nose is being hit by a downdraft, or the plane is being hit by a downdraft. It's not going to stay neutral. It's actually going to get worse and worse and worse. Okay? Three different scenarios for each one of those two categories in regards of stability. Okay? I don't know where the pen went. Ah, here. All right, so if we look here, untitled, I'll take this one. If I would study, I would probably write something like, I'm not saying you have to do it like this, right? But I would write stability. And then here I would go like this, right? And there's dynamic. And there's static. First, I want to know what dynamic is, right? So I would probably write here over time. Like this, static. Almost like a screenshot in that moment. All right, so now I would go down here and it would look like this for me. It would be positive. It would be neutral. And here it would be negative. Same with this one. It would be 1, 2, 3, positive, neutral, negative. Okay. And then here, for example, I would say that after time, it will be better. And you should be able to explain this, right? Neutral is just staying like that. Everybody understand? I'm just trying to give you also hints on how to maybe study, because you got to go back to this maybe 2 months from now, and you know you don't want to spend as much time as you are right now studying. You just want to review. All right. Any questions? No questions. All right. Forces in a turn. What force causes the plane to turn?
Lift.
Correct. Very good. The horizontal component of lift is what makes the plane turn. Okay? It's just like, how can I explain this? You have 100% of something, right? You're going straight level. And if you follow Newton's law now, you're not going to be banking, right? You're not turning because you're going 100% forward. If you're causing any type of bank, you're going to turn, right? Why? Because 100% of lift that is up here will now go or will be distributed to somewhere else. This is 100%, right? Lift like this. If you started to bank, this will be reduced maybe to 75%. These numbers are just made up, right? Like, but 75%. So the other 25% have to be going somewhere. They don't vanish, right? There is a force, and each action has an opposite and equal reaction, right? So the horizontal component of lift is causing the plane to turn. Okay? Your forces are always there. They don't just go away. So instead of going 100% lift, which is here, vertical component of lift, you will now bank the plane and your lift factor is decreasing, but you're increasing what? Your horizontal component of lift. Okay? So that's what makes the plane turn. Because at the end of the day, it always has to be 100. Where the forces go is a different story, but something is causing the plane to turn. Okay? Obviously, you with the input of the aileron causing the plane to turn, but there's 100% at first, and if you turn it, there's not 100% only lift. It's banking, rolling, right? Going somewhere. Is that making sense? Yeah. And then there's also centrifugal force, but we're going to talk about that later. It's a whole all right. Any questions? I mean, it's kind of also easy to understand if you just think about forces, right? Forces in a turn, and where are my forces going? By staying straight and level, there's no turn, zero force. If I'm going to turn, there's some force reducing the component of lift force going into the horizontal component. You are substituting forces depending where you want to go. All right. Let's see what we got next. Forces in the turn. Yeah. If you roll into a turn using ailerons, using only ailerons, your vertical lift decreases and your horizontal lift increases. We just agreed on that, right? It goes from 100 to 80, and then now you have 20 left. That's maybe your bank. The airplane tends to descend during aileron-only turns. If you take the stick and the plane, and you only bank the plane without going back, all right, the plane will turn, but what it tends to do also is, so now I'm here, I bank, the plane goes here. But if you don't add the back pressure, the plane also tends to descend, okay? And we will understand in a minute why the plane tends to descend when you are only banking with no back pressure. You're going like this, bank with no back pressure, right? Only bank. The plane tends to go, it banks for you, but it also tends to go down. All right? Everyone understand that? All right. So, to keep your vertical lift the same so you don't descend, you need to increase total lift by increasing your angle of attack. Now you have to go bank, and to stay here, you have to add a little bit of back pressure. And the reason for that is, or I will describe in a second, okay? So now instead of only going bank and down, you're going bank, a little bit of back pressure. It's slightly really, and then the plane will stay exactly where you want it to be. It's a very slight back pressure, as in pitch up, very slight. But if you only bank, the plane will go down. All right. And that is the reason for it, right here. It's called load factor. I want to see what we have under it. Yep. Before I even go to the chart, I will go to this one right here. Copy this. All right. Next. There you go. Load factor chart. This is a sling. All right, everybody agrees? What's the max weight for a sling that you can take a sling up? Anybody know? Max weight?
So
Who said 700?
You know, like total for the whole thing, it's like 3,000.
Give it a guess.
why not?
Give it a guess too.
800?
Guess.
1,000.
Guess.
700.
Guess. Sean, give it a guess. 700 too?
Yeah.
Jose. Guess. The max weight for a plane and a light for aircraft. Guess. Everybody's guessing.
1,012. 750.
Huh?
750.
1,000? All right.
Oh, sorry. It's not 700 for a kilogram.
Okay. So how much is that
It's
in?
like 1,000, no, it's like 100 kilograms. 1,320.
That's correct. Right there.
1,300. Yeah.
1,320 pounds. Okay, that is the max gross weight you can load the plane for a takeoff.
This is old.
All right. The question is, where can I find this information, right? So go here before we even do this little chart. Here, I show you guys. You don't have to. Chart. There's your POH. Everybody got one, right?
Yeah.
What section was it?
2.5. Your like drop the limitations, bulk factors.
There it is. All right. 2.8. 2.8. 2.8 in the POH. Maximum takeoff weight. 1320. Everybody see that? 600 kilograms. Maximum total weight, total baggage weight, I should say, 33. And this one, I think they even got rid of this one right here. But the thing is that the maximum, me and Stuart, we go up. We already weigh together 350 pounds. Okay. A plane weighs max. The plane that we're taking is, let's make it easy for math purpose. Me and Stuart, we weigh 400. The plane weighs 800 itself, right? 800 plus 400, how much is that? 1200. How much left do we have?
120.
120. 120 divided by 6. Easy math. Right. Right. We can take 20 pounds of 20 pounds of fuel with us, which is the equivalent of 20 gallons. Okay. So we can technically, if I go up with Stuart and we both weigh 400 and the plane weighs 800, the max amount of fuel that should be in that tank is 20. Obviously, this plane can handle much more and is also going through a process where it might be granted 1,500 pounds now, soon. But this only gives you 20 gallons, just for quick math. All right. So now we want to talk about load factor. The only reason why I brought this up is, but you guys got to know these numbers, okay? Like, when you have a time, always read some of the POH. Put it literally next to your nightstand. Like at night, read maybe 5 pages. If this plane, it's a very primitive plane, but I don't know, shit. All right, it's a UFO. Okay, this one weighs 1,000 pounds. Let's say we just weigh 1,000 pounds. Okay, so we're currently at this station right here, right? On the ground, if you're at the run-up, a plane that weighs 1,000 pounds on the ground weighs 1,000 pounds. If you take this plane up now in the air and you bank the plane 30 degrees, okay? Here's your bank angle chart. If you bank at 30 degrees, it's barely anything, but let me make it a little more. If you bank at 50 degrees, you would go here and go left. That's maybe 1.5 approximately. So 1,000 now. Multiply that by 1.5 is how much?
1500.
Your plane that weighs on the ground 1,000 pounds in the air in a 50-degree bank weighs all of a sudden 1,500 pounds. It's just physics. It's forces. Okay? Which means that something that went up 500 pounds is going to descend probably, right? Because weight is stronger. Gravity times blah, blah, whatever. It's going to bring it down. Everybody see now why if I only bank this plane, it will go down? Because the weight went up. Everybody agree? If I bank now, and I add a little bit back pressure, I'm gonna keep that increased weight, load factor, it's nothing else, on the same altitude. All right, so if I take a plane up now, that weighs 1,000 pounds, and I bank at 60 degrees, guess what? 1,000 times 2. All of a sudden, this plane that weighs only 1,000 pounds on the ground, weighs all of a sudden 2,000 pounds in the air. Okay? That's load factor. That's the reason why if you don't add that back pressure as in pitch, you will descend. Everyone understand?
So the chart for the sling looks a lot more, looks get steep a lot quicker. So it just doesn't support, like the load factor increases quicker. at lower
The
angles.
load factor is increasing exponentially.
But for specifically for the sling,
Oh, which one, which chart is
The
it? I can
chart
put it
looks-
up for us here.
it's the one,
2.4.
yeah, 2.4.
Here we
It,
go.
it looks like it increases at a greater rate than the one that you had the example of.
For a second.
Yeah.
Yeah, the other one is the Cessna. The only reason why I showed the other one is because that's also the written one that you will see, okay? You will not see the one for a sling on the written. Yeah, but the factors are different depending on airplane,
Okay.
okay? Well, I was just giving you the example that you will see on the written. But that's correct. Each plane has a different kind of load factor in regards of length. Okay? And they even give you the equation. Nobody expects from you to know the equation in the QH.
I have a
Uh,
question. Sorry, question.
Of course.
For the chart, as you were explaining, if there's a point that the plane should not be exceeding,
Yeah. I mean, in general, the plane, a sling should not exceed 50. Yeah. Or 60, I think it is. Sorry, 60. Because more than 60 is considered acrobatics. Acrobatics, the light sport aircraft is not allowed to do acrobatics. And
what if it happens with that?
it's all right. It's not, it's just a regulation thing. You're not supposed to do it.
But with the plane stall or?
No, I will not so. Yeah, it's a light sport aircraft and then you're not allowed to do acrobatics in it. You're also not allowed to pitch more than 30. Yeah. So that's why we do our spin training in that decathlon. You guys saw the decathlon? It's a different plane there. You cannot put a sling intentionally into a spin either. Because it's a light sport aircraft. Not because it cannot recover, it's just because the regulation says no light sport aircrafts are allowed to be put into a spin intentionally. Okay? And I show you one more reason why. We kind of like drifting off a little bit, so we have to get right back to this. If you're flying the plane and your CFI is sitting next to you, in front of your CFI, there's like glove compartment where you find the POH. The one time I took someone up with me, I've never seen this placard before. The one time I take someone up, they tell me, but this does not comply with federal safety regulation. I've never seen that placard. My entire training, all of a sudden they're the ones who tell me. I'm like, nah, it's all right. Don't worry about it. It's good. It's a good plane. But the reason why is because this aircraft does not comply with federal safety regulations for standard aircraft. That's how you know it's a light sport aircraft. That's how you know it cannot pitch or bank more than a certain degree level. It follows different regulations. Okay? But you can train it, everything's good. It's a really good plane. All right. Back to our charts. There's no way I was here. So, level flight, lift, weight. Medium bank, total lift, weight, centrifugal force, and horizontal component, the turn ratio, right? It's just showing you these forces get greater the greater you bank. The greater you bank, the higher the force, the greater the weight. And you have to compensate that with something to stay straight level. Everybody good? Load factor chart. Adverse yaw. Everybody's favorite. Adverse yaw is the natural and undesirable tendency for an aircraft to yaw in the opposite direction of a roll. It is caused by the difference in lift and drag of each wing, corrected with rudder input. You will hear, for example, let's say you want to go. You go straight and level, and you're about to put the plane in the left bank, okay, like this. Which aileron goes up? Which aileron goes down on the left bank? So we're going here.
The right will go up.
If I go like this,
Right one goes down, left one goes up.
this one goes down like this,
Yeah.
and this one goes up. Everybody agree?
Yeah.
Which one do you think is going to create more drag? the right side. You see how it's kind of like gonna cause the plane to yaw? Even though you're banking, the nose tends to yaw to the right, opposite of your bank. You're banking to the left, and the nose tend to go to the right, and that's what we call adverse yaw. And it's created by that extra drag because of that arrow that is down on the higher wing. Okay? So, arrow is neutral, right? Straight and level. You bank, this one goes up, this one goes down. The nose tends to move right in the left bank. So how do you compensate? You would go up, down, left rudder. And now the nose is gonna follow you because you're also gonna add something. Okay? That is adverse yaw. Adverse yaw is the tendency of the nose to turn opposite of the bank or the bank or turn direction because of the increased drag caused by the ailerons that is down. As simple as that. If we go right now, it would be like this, which means we're trying to bank, but the nose is going to tend to go a little bit to the left. So what do we do?
Right rudder.
Right rudder. We bring the nose with it. Okay. You can tell your instructor in the first lessons to demonstrate Dutch rolls. Okay. It's called Dutch rolls. If you do Dutch rolls, you might be understanding this concept a little bit better. And ask him the sooner you can, not the later. Okay. So you understand the concept of adversarial Dutch rolls. General aviation. Let's see what this guy got. What an intro. I haven't watched this before. I don't know what's about to happen. All right, there it is. You see how his nose is going opposite? He's making it even more so visible to the student or to us. That's what your instructor can do. Instead of only banking to the right, which is here up, here down. Now, what kind of rudder would you put in? For right turn? Right rudder, right? For right rudder, you would put right rudder. For right turn, you would put right rudder. But especially in a sling, it's barely ever felt, okay? So what your instructor can do is to make it even more visible to you, he's gonna add left rudder and make that movement even more so clear to you, okay? So as you would turn now left, instead of actually putting left rudder, he's gonna enhance this experience by actually putting the wrong rudder in. And then you're gonna see your nose is gonna go. So the goal is, wherever way you go, is the nose should always point to the same way, okay? It should not yaw any other way. It should always point to wherever you're trying to fly, okay? And you can have that by rudder inputs. Because you're turning right, or you're turning left, for example, the nose tends to go right. You see how the nose goes up now? I can have an extension here. So I want to go left. The nose wants to go right because of that drag, and you can only compensate that with left rudder, right? So you bring the nose right back to the center where you wanted it to be. Everybody understand? All right. Well, it's not the best video, but I'll find better ones. All right. Turning tendencies. Yeah, good. Kind of good on time. There's 4 types of turning tendencies. Who knows one of them? Who knows a turning tendencies? It's called usually left turning tendencies for us in general aviation.
The P factor and also when I forgot the term for it, but when you have your propeller turning.
Yeah.
With relative wind, that's how we have it. If the wind will start turning in sideways.
Spiral slipstream, yeah.
Spiral system.
I mean, I let you guys almost cheat, yeah.
Oh,
Torque, spiraling slipstream, P factor, gyroscopic precession. Okay. Those are your left turning tendencies. Each one of them you have to be able to explain each one of those. Okay. If I ask you, for example, what is your left turning tendency if you're encountering a spiraling slipstream, right? Or how is that caused through a spiraling slipstream? It is caused very simple. Your plane is on the ground, right?
Hmm.
The propeller is turning which way in the sling? This way, right? So now what's going to happen? It's going to create some type of wind going through the fuselage. It's almost wrapping around the fuselage like this, okay? And when it comes to the back, it's going to hit the vertical stabilizer, yawing the plane to the left. You see it? It's going to left turning tendency caused by the wind that is going around the fuselage until it hits this part, and then that's a left turning tendency. Spiraling slipstream. All right, number 2 is torque, and that will be explained through Newton's third law. Any action has an opposite equal direction. Yeah. So the propeller going to the right makes the plane want to roll to the right, but since it's on the ground, it cannot roll on the ground, right? You're stable on the ground. That pressure now is felt on the back left tire, causing the plane to. All right. And there's P factor. You put your nose up. One side of the propeller is going to eat more of the air than the other side because even the propeller has an angle of attack. Okay? If you're going to look at the propeller, walk outside, there's an angle of attack in regards of the propeller. If you put it up, one side is going to eat more of the air, causing the plane to turn to the left. Left turning tendency. All right. This is in a nutshell. You guys should know this way. And the last one is gyroscopic precession. And that is for usually tail wheel. They sit like this. And when the person or the pilot is trying to bring the tail up, that force now is felt 90 degrees to the rotation of the propeller, causing the plane to turn to the left. Okay. All right. There's a video they have here. You guys. Oops.
It's a little too much.
All right. So, 4 left turning tendencies. Okay. Torque, P factor, spiring slipstream, and gyroscopic precession. Okay. Use this here. Chapter 5, P hack. Highly recommend if you have $20 to spare to buy this book. Keep it somewhere. Read it once in a while. This is probably what each and every pilot has had held in their hands at one time in their life. Okay. It doesn't matter if they're 777 pilots or whatever. This is how all of it works. So if you go here, and now you go to a whole lot of crazy stuff here. Yeah. Look at all these graphs. And let me show you something. There's your axes on the aircraft, right? Aircraft design and characteristics, stabilities. That's what we have been doing all day today. Chapter 5. Different wings. Look at this load factor, right? Seems very familiar, right? Stalls. But what I want to show you is left turning tendencies. There we go. Under this part, torque and P factor is being explained. Yeah, torque right there, torque reaction. And then here, corkscrew effect. And the corkscrew effect is nothing else but the spiring slipstream. So if you say corkscrew and somebody doesn't understand you, you know that they haven't read the book really. All right. So corkscrew effect, or spiring slipstream, gyroscopic action or gyroscopic precession, and how that works. And they explain everything to you. Okay. So after today, Dan asked me yesterday what I would do after class. I would probably read a little bit on this chapter 5 for like an hour or so. And then you will get a little bit of a head start. Not a head start, but you get like, after you did the kings, now you came here, now you're gonna even more so support your knowledge with the PHAC. Okay. And then you're gonna study it a lot. Don't think you're gonna leave this door knowing what P factor is, yeah? Like, you're not gonna leave this classroom knowing exactly what P factor is. You're not gonna leave here today being able to explain it to me tomorrow. It's gonna take a lot of studying. And a lot of patience. All right. Rudder coordination and turns. We pretty much talked about this also when we talked about average yaw, how the nose wants to go the other way when you're actually turning. So you have to add the same rudder input as the turn, but you don't want to overdo it. Because if you overdo it, you're doing left aileron and too much left rudder, you might find yourself in a skid. And that's the worst of all turns to be in. Let me repeat this again. The worst turn to ever be in is a left aileron, left rudder. It's a right aileron or right turn, right rudder. That's the worst of all turns to be in. Okay? Everybody understand? If you overdo it, if you overdo left aileron and too much left rudder, you find yourself in a skid. The worst turn to be in. Everybody just nod your head, so I know you understood. Okay? Left aileron, a little bit of left rudder is good. Left aileron, too much left rudder, you might die. Just put it in like as simple terms as possible. Okay? Especially this turn is famous. Everybody know where base to final is? All right, base to final, you're coming in. Especially in your early stage as a early stage as a student, you're coming in, base to final. This is your runway right here, yeah? This is base. Let's come here. This is base. This is final. All right. How high do you think you are here? Above the ground, max.
1,000.
Maybe 700 feet, 600 feet, right? 600 feet approximately, yeah? AGL. And you see now that you have overshot the runway here. Okay? The first reaction of a pilot who overshoots this runway is going to be, I have to put more left aileron. All right, we agree on that. It can bring you over, right? But now they also want to yank the nose to the left because they see the nose is not with the runway and they're trying to center the nose with that runway. And guess what? They put left aileron, left rudder. And now you're here at 400 feet, right? Off the ground. Everybody agree? And if you do it too much, this plane is going to go from here to here within a second. Okay? I'm not trying to scare you, but I just want you to be very aware. Left aileron, left rudder is a skid. A skid is death on base to final. You cannot recover from a skid. You can have all the training you can imagine of doing in this decathlon. 400 feet is not enough to recover from a skid. A slip, on the other hand, let's say left aileron, right rudder, okay, is going to cause a slip. A slip is okay. You're going to descend with it. And if worst case scenario, something happens, let's say the plane stalls, all that is going to stall is going to be the high wing. And guess what? The plane goes back to normal straight and level flight until you do it again and it goes back and goes back. But here, left turn, left rudder. No, let's see. Left turn, left rudder. Yeah, I always, this is like my imagination trying to kick in now. All right, left turn, foot. Here we go. Is this right?
Yeah.
Yeah. There we go. Left turn, left rudder. Here we go. The plane that is gonna, the wing that is gonna stall here in this case is gonna be this wing right here. And guess what? This wing is gonna take you down like this. All right. On the other scenario, left this way, the wing that is gonna stall is just gonna be the high wing, and all that will happen is this wing will drop, and you will come back to straight and level flight. Okay. Skid and slip. Very important. Questions on that? Nope. Good. A skidding turn, too much rudder causes a skid. Up aileron creates lower angle of attack. It's the worst of all turns.
Is that also how you create spirals and spins? Or just using skidding turn?
Spins?
Yeah.
Oh, yeah, you can end up exactly, yeah. Yeah. But you don't have time to recover. On base to final, you don't have time to recover. It takes 500 to 1,000 feet to recover from a spin. And you're 400 feet off the ground. Does it make sense?
Pattern altitude.
Yeah, but now you're on base.
Oh,
So you already went down 200 on final. And now you went 200 down on base. And now you're trying to turn, right? So you're about 500 feet off the ground on final. And now you're skidding. So you're 500 off the ground. And it takes about 1,000 feet to recover, 500 to 1,000 feet to recover from split. Okay? All right, I'm not trying to scare you, but and if you feel like seeing a proper short approach, maybe ask your instructor to see what a short approach is like. Maybe don't ask him. I don't know who your instructor is. All right, three types of parasitic drag. There is interference, friction, and form drag. Put this real quick in a nutshell. So we already talked about this a little bit. There's form drag. Any object flying through air is creating drag, right? A truck going through the freeway is creating drag. It's probably creating more drag than a Ferrari, right? Because one is more aerodynamic than the other one. It's the form, right? The form of the object going through air. Parasitic drag. A Ford Transit, those car or pickup truck, a pickup truck, F150 is creating more drag than a Lambo, right? The form of the plane or the form of any object going through air is going to create drag. That's called parasitic drag. The next one is going to call interference drag. Interference drag, anywhere where you find a 90-degree angle between, for example, the wing and the fuselage, that 90-degree angle right here at this corner is going to create a drag considered to be the interference drag. And that interference drag, you remember when I told you yesterday, I will tell you what the fairings are about. The fairings are there to reduce the amount of interference drag because it's now creating some type of a curve, less of 90 degrees. Therefore, we are talking about what? Less drag, less interference drag, less than 90 degrees. Friction drag, last one in the parasitic drag section. Friction is even if a plane looks very smooth, right, with that gloss painting on it, if you put it under a microscope, there's some unevenness on it, right? And that is, for example, that causes friction drag. A bug, for example, causes friction drag, right? Your antenna sticking out, that's calling friction drag. Everybody understand? Interference, 90 degree. Form, any object going through the air. Last one is friction. Anything, even on the microscopic level, is uneven, as glossy as it might seem. That's what the book says. Last one, there's parasitic drag. The more aerodynamic it is, the better. But it's still creating drag. Even the smoothest of all cars, the smoothest of all planes, the stealth bomber is still creating drag, right? It's going through air. Induced drag. All right, parasitic drag, put on top of it, independent from lift. Has nothing to do with lift. Induced drag, put on top of it, directly related to lift. Okay, as simple as that. So, as soon as the airplane takes off, induced drag is created. Induced drag is the result of pressure equalization between the high pressure and the low pressure, blah, blah, blah. Induced drag is directly related to lift. Okay? It is high at the beginning, especially when he's trying to take off, and it gets less the closer you get to your cruising speed or your cruising altitude, right? Because you're not creating that much lifting. You're creating some type of lift, but not as much as it was at the very beginning. All right. We will, and this is just aerodynamic. You see form drag, they have like a lobster is much more aerodynamic than, I don't know, just dog, whatever, or a cow, or a chicken standing up, right? Like aerodynamic and drag, parasitic drag, any form going or any object going through air is going to create drag. The more aerodynamic it is, the less it will create drag, but it still creates drag. All right, good job, guys. Wait, do I have everybody on the attendance? Think so. Let me know if I don't, because I'm about to submit it. So if you see your name, yell before I press. Oh no, Arsani is here, right?
Yeah.
All right, I'm submitting it. Tomorrow you're gonna have it with Zachary. So I'll be back Monday. Fine.
For the induced drag fire, is this the one that we were talking about with the attack angle and then it's perpendicular to your attack angle? That's what it is.
Induced drag is directly related to lift. It's a direct induced drag. It's directly correlated to lift. Okay, so if you create lift, you
Uh-huh.
create drag.
Okay,
It's simple as that.
we're not talking about like the figure, right? How much angle?
Yeah, the more angle you, the more lift you create, the higher the drag.
Oh,
Okay.